Hello everyone. In this video, let's try and solve this problem. We have blocks A, B, C, and D are all attached. Okay, attached. Are all attached to a pulley system as shown below. Block B is moving 3 meters per second downward while block C is moving 4 meters per second upward. Determine the velocity of block A relative to block D during this time. Okay, let's try and solve this problem. Now, this problem is a mixture of both dependent and relative motion. The dependent motion in this problem is that we have blocks within a pulley system. So notice that if A moves, it will affect the movement of B and C. Also, if D moves, it will also affect the movement of C. So we have a dependent motion here. Also, the question is relative velocity. So in the question, we are also asked with the relative motion. So this is a mixture of relative motion and dependent motion. So let's start first by determining what is asked in the problem. We have determined the velocity of block A. So the velocity of block A relative to block D. So we have velocity of block A relative to block D. To solve this, we need the velocities of A, block A minus the velocities of block D. Now, what are we given with? We are given with the velocities of block B. The velocities of block B is going downward. Now, since all of our blocks, A, B, C, and D, only have two types of movement, it is going up or going down, so it will be best to assume a positive and negative direction. So I will assume going up is the positive while negative is the going downward movement. Velocities of block B is 3 meters going downward. So I'll have it negative 3 meters per second. While the velocity of block C, it is 4 meters going upward. So it's positive 4 meters per second. To solve the question of the problem, we need A and D velocities. But we are given with B and C. So how do we get the velocities of A and D? Okay, this is now where the dependent motion analysis comes into play. So when we have a dependent motion analysis, most of which, especially for pulleys, we can solve the problem by analyzing the movement of the rope. Now, note that in these types of problems, it is commonly assumed that the rope does not stretch, or the stretch of the rope is not critical that it will affect the problem. Okay, so we shall assume that the rope is rigid and it will not change in length even after the blocks are moving. Now the question is the velocity of block A relative to block D during this time. So notice, so the question is, what is the relative velocity during the movement of B and C, meaning their movement is 3 and 4, what is also the relative velocity? So we no longer need to compute the movement after a certain period of time. So time is not a factor in this problem since we only need to solve the velocities of A with respect to D at these specific velocities. Okay. So let's start. Since we have independent motion analysis, as I've said before, it is best to start your analysis with the rope. So we have here our first rope, this one starting from A, it connects up until C. So we have this length here, we have it length of A plus, over here it is connected to B, so that is your length of B, plus, this is also a rope connected to B, so another length of B, plus, and then the rope ends here, connection to C, so length of C. So this is now the total length of the rope 1, total length, no? Total length of 1, that is, or we'll have it LTs of 1, this is the first one. Now if we take the first derivative, we will get the velocities at A, velocities at B, velocities at B, velocities at C. The derivative of the total length is 0 because the length of the rope is constant. it will not extend, it will not stretch. So if it is a constant value, then its first derivative is 0. So we now have our first equation. We have VA plus 2VB plus VC equals to 0. Now we have values for VB and VC. So by substitution, we have VA plus 2 times VB. VB is negative 3 since we assume going downward is negative. Plus VC 4 equals 0. So we have VA is equal to negative, let's do this here. Okay. You have transpose negative 2 times negative 3 minus 4. So we have 2. So we have 2. Okay. Because if we can transfer it here, we have negative 2, negative 3 minus 4. Okay. We transfer to the other side. The positive 2 becomes negative. So copy negative 3, transfer to the other side, becomes negative. So you have negative 2, negative 3, negative 4. Yes, is 2. So the velocities of A is 2 meters per second positive, meaning it is going upward. So we now have our VA. The next problem is now for VD. We analyze now the rope. For this one, we have the length of C. This is the first part of the rope, plus the length of D, since it is connected at D, equals for the total length of the rope 2 for the second rope. Take the first derivative equals to 0. So VC plus VD equals 0. Okay, we have the velocities of C. Substitution 4 plus VD equals 0. So we'll get VD is equal to negative 4 meters per second. Or in other words, VD is going downward. Substituting the value of VA and VD, we have the velocities of D relative to D. VA is 2 minus negative 4. Negative 4. We will have 2 minus negative 4. This becomes positive. So this is now 6 meters per second. Okay. So we now have the velocities of A relative to the velocity of D. 6 meters per second positive. What this means is that if you are, this is the velocity of A relative to the velocities of D. What relative motion means is that if you were standing here at block D, you will see the block A having this kind of motion. Okay, so you are standing at block D and you will see that A is moving to the positive direction at 6 meters per second. So if you are block D, you will see block A going to the positive direction at 6 meters per second. Okay, that is what is meant with the relative motion. So we have the answer for this problem, 6 meters per second.